Hello. So today I want to talk about these topics: quantum number, orbit, orbital, electronic configuration, and use of electronic configuration for bonding. Now, if we consider about the quantum number, so the quantum number first. So we know that we have four different quantum number necessary to identify each and every electron in a orbital. Okay, so we have four quantum number I said as one principal quantum number. I will write only Q and N, principal quantum number, and two azimuthal or subsidiary quantum number. Three is a magnetic quantum number. And four is our spin quantum number. Now, if we look at principal quantum number, it is denoted by N, which actually define the orbit. Orbit means the region which is allowed path set by Bohr. So its value always integer 1, 2, 3, 4 like that. Okay, 1 equal to 1 means first orbit, 2 second orbit, third orbit, fourth orbit. Okay, and the L is the subsidiary quantum number, and I will discuss about its value later. And the magnetic quantum number is actually M, which determine the subdivision in the orbital, and L determine the orbital. What is orbital? Orbital is the area where the probability of finding electron is more than 90 to 95%, or we can say that probability of finding electron is maximum. So how we can explain this? If we look at this paper, so we know every atom has some circular path around it according to Bohr. Now this path is known as orbit. Okay, now electron cannot reside in all of the position of this orbit. Okay, there is a probability for residing the electron at a certain time at a position. This probability of the finding electron around this orbit is known as orbital, the region. Like if it is available within this region, then we said this part of a orbit is a orbital. So this part is basically, we can say this part is orbital. Okay, this part is orbital. All of these are orbit, and this part is basically orbital. So that means orbital is a part of orbit where the probability of finding electron is maximum, or sometimes we can say 90 to 95%. Okay, now coming the point that, so if we consider that the value of L, now L value actually determine the orbital. Which orbital? If L equal to 0, then it is S orbital. If L equal to 1, then it is P orbital. If L equal to 2, then it is D orbital. If L equal to 3, then it is F orbital. Okay, so now we will find out the value of N and L and M based on the value of N. Now if we consider that N equal to 1, now if it is N equal to 1, then L equal to always 0 to N minus 1. Now if it is 0 to N minus 1, that means 0 to 1 minus 1. That means 0 to 0, which implies L equal to 0. Okay, so if N equal to 1, then L equal to 0. This is only one point we can say. Now if N equal to 2, then L equal to 0 to N minus 1. So 0 to 2 minus 1, so 0 to 1. So that means if n equal to 2, then L equal to 0, 1. Again, if n equal to 3, we can consider another case. Then L equal to 0 to n minus 1. So 0 to 3 minus 1. So 0 to 2. That means 0, 1, 2. Because we know that to go to 0 to 2, we need to include 1. Now, if n equal to 4, then L equal to 0, 1, 2, 3. Because n minus 1. Okay. 4 minus 1, 3. Clear? Now, you can consider that what will be the value of m. Now, for the m value, we always get, we do the set. You can remember the set in the algebra. So for the set, we always find out the some value for x and y. This is called set. Okay, or we can say 2, 3. Then we can say that value of x is 2, value of y is 3. Now, similarly, for m value, for the magnetic quantum number, we always obtain the similar value from the set of n and l. Orthat, if we look at n equal to 1, then l equal to 0, then only one set is possible, n and l, only one set is possible, that means 0, 1 and 0, nothing is possible. So the value of m equal to 0. So this is actually represent the 1s orbital, and each and every m value represents 2 electrons. So in 1s there will be only 2 electrons. Okay, now go for the second one. Now if we look at that, then if we consider n and l, then we will get two different set. One is 2, 0 and 2, 1, 2 value. So for 2, 0, we obtain m equal to 0, and for 2, 1, we obtain m equal to, always the value of m is, value of m always defined by value of m equal to minus L, 0 to plus L. So we can remember we do some math. So if it is minus 1 to plus 1, then it should be minus 1, 0, plus 1. If it is minus 2 to plus 2, then it is minus 2, minus 1, 0, plus 1 and plus 2. This is the basic mathematics. Okay, so now if we look at this information implies that, if you look at this information implies that you have m equal to minus 1 to plus 1. Okay, because L equal to 1, then the m value will be minus 1, 0, plus 1. Again, for n equal to 3, now I think it is okay. For n equal to 3, we can prepare n and l set equal to 3, 0, okay, then 3, 1, then 3, 2. Okay, we have 3 different sets for n equal to 3. Then for 3, 0, m equal to 0. For 3, 1, m equal to minus 1, 0, plus 1. For 3, 2, m equal to minus 2, plus minus 1, 0, plus 1, plus 2. Now if we consider another another one, n equal to 4. So all of them are same, but if n equal to 4, we will obtain another extra. So if n equal to 4, then L equal to 0, 1, 2, 3. So along with the 3, we obtain only one extra for n and L value, and it is 4 and 3. Now if it is 4 and 3, then we can say that m equal to minus 3 plus minus 3 minus 2, then minus 1, then 0, then plus 1, then plus 2, then plus 3. Now we consider that, so if you look at, so this m value is for L equal to 1. Now we said that L equal to 1 means p orbital, okay, and m equal to 2, this is for 2, and m equal to 2 means L equal to 2 means we said d. So this will be 3d, this will be 2p, and this will be 4f. Okay, now how many subdivision in a orbital? How can we find out? It is easy. You can see the subdivision in p orbital is 1, 2, 3. So 3 subdivision, and I said each and every m value represent 2 electron. So p could highest obtain 6 electron, 2, 2, and 2, total 6 electron, and as a result p, we write always p can accommodate maximum 6 electron. Again, if we look at d, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so d have 5 subdivision. So how many electron there? So it can 5 into 2, 10. Okay, and now if you look at f, then 1, 2, 3, 4, 5, 6, 7. So how many subdivision? 7. So how many electron? It is 14. So this is the easy method for determining how many electron will be reside in each orbital, and how we can get the idea of orbital from the quantum number as well as the value of quantum number from any calculation. Okay, so this is our total calculation, and also this page I am keeping for your information. Okay, so yeah, so we'll come with the next lecture about other things. Okay.